This video is dealing with how to break forces into their components. So if you have, let's maybe start with the force just acting horizontally. So if you had a force of 100 newtons, someone pulling a box with a force of 100 newtons there, and someone pulling with a box of 20 newtons there, to work out your net force, or your overall force, your total resultant, they're all basically the same thing. You would basically say this force minus that force. So 100 minus 20 newtons, which gives you 80 newtons. Now, forces are vectored also needs direction. So you have to say the ultimate force at the end is 80 newtons to the right. That is if your forces are all in a straight line. If you had another object and someone was pulling it with a force of 100 newtons, someone else was pulling it with a force of 40 newtons, and someone else on the side with a force of 50 newtons. Notice also that when you draw your arrows, they should look, and this one actually is not correct, they should look like in proportion. So that is a fifth the force of that one. So this arrow should actually be a lot shorter when I'm drawing it for proper marks in a test. So then for this one, if the forces are acting in the same direction, I add them together. So I would say 100 plus the 40. Then this one is acting in the opposite direction, so I minus that. So it gives me 140 minus the 50, which gives me 90 newtons. And again, the bigger force is to the right, so the overall force is to the right. So ultimately what this means is this box will end up moving with a force of 90 newtons to the right. Now, what if you have an object which is not acted upon by a force that's perfectly horizontal or vertical, but rather at an angle? So let's say that. So let's say you're applying a force of 100 newtons. Let's say there's friction on this box of, let's say, 10 newtons, and you have to work out the net force. Now, what you are not allowed to do is you are not allowed to go 100 minus 10 newtons. And the reason for that is because these forces are not in a straight line, okay? Whenever forces are not in a straight line, you're not allowed to subtract them from each other. So you could subtract these forces, or even if they were vertical, you would be allowed to do those, but you can't, for example, add those together if they're not in a straight line, okay? So in this case, what you have to do is you have to break the force up into components, into an x component or horizontal component, okay, let's call this fx, and into a vertical component, which we call fy. Now, how to look at this? Previously, if you've looked at the worksheet so far, is they have given you these two forces, and they've asked you to work out the resultant. So they said, for example, something is being pulled with a force like that and with a force like that, work out the resulting or the net force. Now we know that this thing would end up moving in this sort of direction if someone's pulling it up and to the right, and you call that the net force or the resultant force. Now what they're doing essentially now is doing the opposite. Now they're saying to you, if one person is pulling the box with a force like that at 100 newtons, how could I replace that with a vertical or a horizontal force that would have the same effect as this force? So I'm working in reverse essentially. I'm giving you the net force, or what is usually the net force, and I'm asking you to work out if two people were to exert a force on this box, what would they have to exert to have the same effect as that 100 newtons? And you call that the fx and the fy. Now, first thing is draw this into a triangle. Okay, it's very difficult to do this without drawing it into a triangle first. So we are going to do the x component. It doesn't matter which one, you'll see as well. The memos will have two options. It doesn't matter which way you draw first. You can draw the y component first and then the x component and then draw your final one. Or you can draw the x and then the y. It doesn't make a difference, okay? For the sake of what I'm going to try and explain now, I'm going to draw it this way. My angle, okay, they'll have to give me, let's say the angle is 30 degrees on this diagram, which means the 30 degrees fit in here, like that dotted line, that's this line, and this is my fx, so that's perfect. So the 30 degrees fits in right there in my sketch. So then I know this, like we said, it's going to be the opposite of normal. Normal, we have those two and we're working for this out. Now I'm given this and I have to work out those two components. Now if you're just doing trig, so SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now remember, adjacent and opposite depends on which angle you're looking at it from. So if I'm looking at it from this angle, this side is adjacent to that angle, this side is opposite, and the one opposite the 90 degrees is always the hypotenuse. So I have the hypotenuse and I'm looking for either the adjacent or the opposite. Let's start with the adjacent. So let's say sine of 30, because I have the, let's start with this one. Sine of 30, I have the hypotenuse and I want the opposite, is equal to O over H. So sine of 30 is equal to Fy over the hypotenuse, which is 100. Then to get Fy by itself, I'm going to cross multiply. Remember, this is over 1. And then it is Fy is equal to 100 multiplied by sine 30. Okay, so we just press 100 multiplied by sine of 30, close brackets, and we get 50 newtons. Now remember, any force needs a direction. So you'll see on the live worksheets, there's always two spaces for force because you need the size, the unit, don't leave any spaces on the live worksheets, and the direction, which in this case would be up. Your x component, okay, we are going to say that we want the adjacent and we have the hypotenuse. So we're going to do it as cos of 30 is equal to adjacent over hypotenuse. So the adjacent is what I want. So cos of 30 is equal to fx over the hypotenuse, which is 100. Then cross multiply again. Okay, then you get fx is equal to 100 times cos 30. So 100 multiplied by cos 30, which gives me 86,60 newtons. And in this case, this thing would have to get pulled to the right. So I'm going to say to the right. Now, there is a shortcut you'll see on the live worksheets as well, which one of my matric years actually came up with, which I thought was quite cute. It's y sine if you can cos x. And there was their little clever way of remembering when do you use the sine and when do you use the cos. If you're working out the y component, then you say the force, this force at an angle, multiplied by sine theta. And if you're working out the x component, it's that force multiplied by cos theta. So that was their clever way of doing it. Now you're welcome to do that. It saves you having to draw the triangle every time. However, this only works, and you'll notice that's why I didn't want to draw the triangle this way. It only works if you are going to use the angle made with the x-axis. In other words, if the angle that they gave you here was this angle that is next to the y-axis or next to the y component, don't use that. Okay? My rhyme or the rhyme only works if you're always going to work with the angle made with the x-axis, which is very easy. This is always going to be 90 degrees between the y and the x component. So you could just say 90 minus 60 and you can get the 30 degrees. So quite a nice, simple way of just doing it. You do need to know how to draw the triangle though. There have been questions in exams before where they've asked the grade 11s to draw a triangle. So you need to understand where it comes from. But if they're not asking you, which is most of the time, this is just a nice, cute, clever, quick way to do it. Now let's go back to the original question. Now let's say that you have this force being pulled at an angle. I've now broken it up into two components. My x component was 86,6 newtons and my y component was 50 newtons, and there was friction of 10 newtons. Now if this happens, what you need to do now is, so basically what we're saying is these two forces have the same effect as this one force. That's why you'll notice I'm not drawing that force again. I've basically found the two forces that have the same effect as that one force. So that force is gone now. The next thing you'll have to do now is you have to subtract or add any forces that are in a straight line. So in this case, you'll have to add or subtract these two. So I'll call that Fx net, just so I know that that's not just one of them, that's the overall. And I'm going to subtract them because they are in the opposite directions. And I get 76.6 newtons still to the right. Now my y force is just 50 newtons. Okay, there's no other forces down. I'm just taking it from the information I'm seeing. I don't have to work out anything else. Then what you're allowed to do is draw this into a triangle. Now it's simple. Once you've broken it up into components, it's actually very simple. So then you say it is 50 newtons. And again, it doesn't matter which one you draw first. So I'm going to draw up and then I'm going to draw to the right. Okay, now it's very simple. Now, if you want to figure out what direction this box will ultimately move, you'll just have to draw in your resultant or your net. Your theta is always drawn where the two tails meet. Remember that the forces that you add together have to be drawn head to tail. So where the first one stops, the next one starts. But your resultant force, your net force, is always drawn tail to tail and head to head. Tail to tail, head to head. Your theta is always drawn where the two tails meet. Okay, so not there. There's a head and a tail that meets there. Then it's just going to be Pythag there. So F net is equal to 76.6 squared plus 50 squared. Then you'll just have to square root it at the end. And you get an answer there. It should be bigger than either of those, isn't it? Because it's the hypotenuse. Newtons. Now again, force is a vector. Now what I often find is people will stop here because they think they're done. Remember that force is a vector, it needs direction. So you need to work that theta out. Now notice, and you'll notice on the live worksheets as well, I try not to ever use the hypotenuse. I try to use my adjacent and my opposite, so tan. And you'll see you're pretty much always going to use tan. The reason is if I made a mistake in my hypotenuse, I'm going to carry that mistake over into the angle. So this is a safer way. I mean, there's also obviously a chance you could have made a mistake there, but it's just one less step to make a mistake in. Then you will remember to shift tan, 76.6 divided by the 50, which gives me an angle of 56.87 degrees. And if you look at how bearing works, remember with bearing, you're drawing a Cartesian plane where the two tails meet, and then you're measuring from north clockwise until you get to this dotted line. I like drawing my F net as a dotted line or a different color line, just so I know where I'm always going to. Now this one actually is very nice because it's not me having to add 90 degrees or subtract it from 180 or anything like that. I'm literally just going to go, my final answer is equal to 91.47 newtons at a bearing of, and that theta is literally my bearing. It's clockwise from north, it's perfect. It's nothing that I need to do with that. So 56.87 degrees.